All right, theorem 11.7. If two polygons are similar with the lengths of the corresponding sides in the ratio A to B, then the ratio of their areas is A squared to B squared, okay? And we'll practice that. We'll take a look at what that means. Do you want me to draw you a picture of what that means?
Yeah, it makes sense.
Yeah, it's just like if you have a small rectangle and they're similar, a bigger rectangle, and you have side A here and B here. They're similar, but they're not the same. Okay, they set up as a ratio, A to B. If that's true, then you can say the areas are A squared to B squared. They're not, you can't set these equal to each other. You just know that you can square A and square B and get that area and set it up as a ratio. You'll see when we work with it, okay? All right, in this diagram, it's telling you that figure 1 is similar to figure 2. Therefore, you know that you can send up ratios of corresponding sides. And it tells you that they're similar. Find the indicated ratio. So first we have to find the ratio of the perimeters. Well, from a theorem, I don't remember the number of it, we learned that the ratio of the perimeters is the same as the ratio of corresponding sides. So we can just set up our ratio of corresponding sides, 18 to 10, reduce it, and it would be the same as the ratio of the perimeters. That's our answer. Then the ratio of the areas. Well, if this is the ratio of the corresponding sides, we could say that's A, that's B. To write the ratio of the areas, we just square A and square B. So we would do 9 squared over 5 squared, which would be 81 over 25, and that's the ratio of the areas. And then we'll be able to use that to help us solve problems. Okay, that's what we're going to do today. Use basically these two ideas here to solve problems. Okay, you are painting a ceiling of a room. You need 7 quarts of paint to paint the larger ceiling. That's going to be information we'll use. How many quarts do you need to paint the smaller ceiling? Well, in order to think about how much paint you need to know area, right?
Yeah.
Basically, you usually work with area when you figure out how much paint you need. So when I look at this picture, they didn't give me the area, but they gave me corresponding sides. Doesn't really tell you they're similar, but we're going to assume they are similar. So this side is 10, this side is 14. So the first thing I'm going to do is set up the ratio of corresponding sides. And from that, I can get the ratio of the areas. So I'm going to say, okay, 10 to 14. And that reduces to 5 over 7. So there's a ratio of corresponding sides. Now, I know in order to paint, I need the area. So I can get the ratio of the area by squaring both of these. And that's 25 over 49. Now, what would be the next step? If I know I need 7 quarts of paint to paint a larger ceiling, what can I do with this ratio to help me figure out how many quarts of paint I need to paint the smaller ceiling? What do you think? Put your phone away. Anybody have any ideas? Often when you're working with ratios, you can set up a what to help you solve stuff? A proportion. So, I know with paint I need area. What other information did they give me? 7 quarts. Now this is my small room, and this is my large room, right? And I need to know how much paint I need for the small room. That's my unknown, but I know I need 7 quarts for the large room. Oh, I can use a proportion to solve this. You just have to think about it a little bit. How would you set that up? So then, you can solve this by cross-multiplying, correct?
Yes.
Or in one fatal swoop on your calculator, do you remember how to do that? 7 times 25 divided by the third number. Okay? This is the area. I'm just going to clarify so when you're looking back at it, and this is the paint. When you do 7 times 25 divided by 49, what do you get?
3.6.
Approximately 3.6. So can you buy 3.6 quarts of paint?
No,
So you would buy what? 4 quarts. And if instead of buying 4 quarts, it might be cheaper to buy a what? A gallon, right? Just a thought. Okay? All right. Oh, there's more. Isn't this fun?
No.
Okay. I'll be honest with you. I'm going to pause this. All right. A small flat screen TV is 24 inches wide and 18 inches long. All right. A larger TV is similar, so I know I'm going to be setting up stuff ratios, to the smaller one. The area of the larger screen is 657 square inches. Find the width of the larger TV. So when I read all that, I think, I don't know, personally I'm a visual person, so I'm just going to draw a little picture here. So a small flat screen TV is 24 by 18. So I'm going to say that 24 wide by 18 long. That's what the W and the L represent. It doesn't really matter where you write it. It makes no difference. And then the larger TV is similar, and they told me that that has an area of 657 inches squared. And I'm going to say this is my width and this is my length because they're similar, right? I need to know this. That's what I need to know. So, let's see. I don't know what I can do right now, but I know that I'm going to be working with this theorem, and I'm probably going to have to set up some ratios. I think right now I could set up a ratio of the areas. I only have one area, but can I get the second area? Yeah. So that probably is something I would try and do. So I would do 24 times 18. Find the area of the smaller TV. Okay, so that is 432 inches squared. 24 times 18. Okay, then use theorem 11.7. So if I set up a ratio of the areas, I can then also use the ratio of the two corresponding sides. So I'm going to set up the ratio of the areas, which is 432 over 657. Now pause a second. This came from the ratio of the corresponding sides squared, didn't it? Right? Because that's what that theorem says. If we know the corresponding side ratio, we can square it and set up an area ratio. So I don't know both of these, but I know this one, the smaller one, right? See what I'm saying? So I'm going to now write this, 432 over 657, realizing that my smaller one is on top. This is where I screwed up before. And I'm going to do width over width here, which is 24 over my unknown. However, I have to square these, so it looks like that. Because these are not equal. That's the confusing part. The corresponding side ratio is not equal to the numbers you get for the area unless you square them. You have to square A and B to get the ratio of the area, right? And this is my A and this is my B. Okay? I had to square them to get the area. So consequently, I have to square them to set them equal to each other. Make sense? You have to think about it a little bit. It's tempting to not square them, but that's not true. You had to square them to get the area, right? Okay. So now you can just cross multiply. So 432 times x squared equals 657 times 24 squared. I don't know what that is. Somebody tell me. If I cross multiply these two. It's a big number. No, 657 times 24 squared.
378,432.
Yes, do you agree, everybody? 657 times 20. What? 432? Okay, yes? I'm just trusting that that's right. Then what do you do now? Divide by 432?
Isn't that x squared though?
876.
Oh yeah. Fine. Sorry, order operation.
Then square root. And what do you get? What'd you get?
29.6.
Okay. Find the width of the larger TV. So remember, we're working, x is approximately 29.6. So let's just round it to 30 inches. And does your answer make sense sort of to your picture?
Yes.
It needs to be bigger than the smaller one, correct?
Yes.
All right, so always double check that before you walk away from the problem. Make sense? Little tiny things, like before, when I was doing this, I had these two mixed up. So I had 18 here, and I could not figure out where they got the answer from. So just be careful with how you set it up, yeah? Take your time with that. All right, here. The Pentagon in Washington, D.C., we saw that on the bus. We drove by it. You guys remember?
That's the like defense.
Yeah, and it's shaped like a pentagon. It's got 5 sides, yeah. The Pentagon in Washington, D.C. is a regular pentagon. That's an important word. What does that mean? All sides are equal. Each side of the base is 900 feet, and the area is 1,400,000 feet squared. You have a scale model of the pentagon for which the perimeter of the base is 30 yards. Oh, wait a minute. We have a problem because here we have yards and here we have feet, right? So let's pay attention to that. Find the area of the base of the model to the nearest square yard. Okay, again, I'm sorry. I have to draw pictures. It's just the way that I work. So here, I'm going to draw a pentagon. And I know that one side of the actual pentagon is 900 feet. And I know that the area is 1,400,000, so I'm just going to write that inside. Feet squared. Okay, then I'm going to draw my model. A little bit smaller, it doesn't really matter. What I know about my model is that its perimeter is 90 feet. Wait, no. Oh, that's where I screwed up. 30 yards. I know it's 30 yards, okay? So, it's easier to convert to feet than to convert this to yards. And then we'll fix it at the end so that our answer is in yards, all right? So, this is where I made the mistake that drove me crazy yesterday. Converting 30 yards to feet. So in my head, I'm like, okay, I got to multiply that by what? 3. I wrote down 900. And I kept doing this whole problem with 900. I'm like, what is wrong? Duh. So just be careful. That equals 90 feet, right? Now, so far I've been working with setting up a ratio of corresponding sides. All I have here is the perimeter. I could do the perimeter, or I could do 90 divided by what to get one of the sides? 5, because there's 5 equal sides in a regular pentagon. So I'm going to do that. 90 divided by 5 equals 18 feet. Oh, now I think I have what I need to find the area of the smaller one. I can set up a ratio of corresponding sides. Correct? Square it and find the ratio of the corresponding areas. Make sense? All right, so let's do that. Set up a ratio of the corresponding sides, 900 over 18 If I square that ratio of corresponding sides, I can set it equal to the area of the corresponding areas. So 1400 over my unknown area. You with me? Okay. It's a kind of big, ugly numbers. So actually, I looked at this and I thought, I wonder if I can reduce that. I don't know where my calculator is. You can reduce this. Put this on your calculator. And watch. Use the math button to see if you can reduce it, and it'll be a lot easier to work with than those big, huge numbers. 900 squared divided by...
I can't see it.
You can't see it? 2,500. So I'm going to reduce this fraction to 2,500 over 1 equals 1,400,000 over x. Then it's a little easier to work with. I just did this on my calculator, pushed enter. It's 2,500, and then I wrote it as 2,500 over 1. Got it?
Yes.
Okay. All right, so now we cross multiply. But really, you can do it all in one fatal swoop, correct? This times 1 divided by 2,500. I know you're having fun with this. Times 1, all divided by 2,500, equals what? What do you get?
560.
560 feet squared, and then we walk away from that problem, correct? No. Why are we not done? We have to convert it to square yards. Okay. So what do you think you do? You want to divide by 3, don't you? But that's not right. We're talking square yards here, okay? So let's think about this. If I have a square yard, how many feet are in a square yard? 3 feet and 3 feet, right? So how many feet squared are in a square yard? 9. 9 feet squared in every square yard. Oh, see it? So you could set it up like this. 560 feet squared times 1 yard squared over 9 feet squared. For every 1 yard squared, there's 9 feet squared. So you have to divide by 9. Yeah? Tricky, tricky. Equals about 62 yards squared. So this is a lot more problem-solving stuff. Okay? Not a fan.